Welcome to this explainer. Okay, so if you've been following artificial intelligence lately, you already know we're basically living in the era of the Goliaths. I mean, we're talking about massive, insanely resource-heavy AI systems, the ones that need just staggering amounts of computing power, energy, and frankly money just to function. But right now, there is an exciting, massive academic shift happening behind the scenes to shrink these giants down to size. Today we're diving into the ultimate David versus Goliath story of the tech world, the 2026 Parsimony Movement.
So, what's the secret weapon being used against these AI Goliaths? Parsimony. Now, by definition, parsimony means exercising extreme care with resources and efficiency. It's literally the art of achieving more with less. And in our story, parsimony is this clever, nimble David that's systematically proving to the tech world that, hey, bigger isn't always better. It's all about building absolutely brilliant systems without all those bloated resource costs.
Okay, let's dive into this. Here is our roadmap for today. First up, the push for parsimony. Second, trimming down massive models. Third, the power of quantization. Fourth, small models making a big impact. And finally, real-world parsimonious AI.
Section 1. The push for parsimony.
To really grasp this movement, we need to visit the specific battleground where this technological shift is taking off. Back in March of 2026, researchers gathered in Tübingen, Germany for the Conference on Parsimony and Learning, or CPAL for short. The whole crux of this movement, as seen in Volume 328 of these machine learning proceedings, is a stark contrast. On one side, you have giant AI. It relies on massive resources and comes with, honestly, incredibly high operational costs. But on the other side, you have parsimonious AI. This is what these researchers are actively championing. It's nimble, it's highly efficient, and most importantly, it is accessible. The entire goal here is to actively move away from those giant models of yesterday to make AI cheaper and faster for everyone.
Section 2. Trimming down massive models. So, how exactly do we get from giant AI to parsimonious AI? Well, one major strategy is quite literally trimming the fat off these giant systems. Researchers are using these highly sophisticated techniques, known in the field as pruning and sparsity, to basically hollow out the bloat while keeping the brain completely intact. Now, you gotta love academia for these wonderfully complex, jargon-heavy paper titles, right? But the core insight here is actually simple and brilliant. These papers show us highly concrete ways to mathematically slice away unnecessary data from language models without losing a single drop of their accuracy.
You know, what I found genuinely fascinating here is the Rose paper's approach to something called one-shot pruning. Rather than slowly and painstakingly removing little bits of data over countless training cycles, one-shot pruning is essentially a highly precise surgical strike. It just goes in, removes the excess weight, and makes the language models drastically smaller in a single, highly accurate go. It's like a magic trick.
Section 3. The power of quantization.
Beyond just trimming models down, there is another massive trend popping up to shrink AI, and that is quantization. Think of it this way. If pruning is about trimming the unnecessary branches off a tree, quantization is about compressing the remaining wood itself. Papers like LLMQ and lattice-based vector quantization prove that we can actually drop the mathematical precision just enough to save massive amounts of space. And the kicker? We do this without sacrificing the AI's actual intelligence. This lets the computer do way more with significantly less memory.
And here is the absolutely crucial point about why this matters to you and me. The LMMQ paper, authored by Eric Schultheis and Dan Alistar, proves that by using this efficient, lower precision training, everyday people can now train powerful AI on standard consumer graphics cards. We're talking about the kind of hardware you might already have sitting in a gaming PC right now. This completely bypasses the mega corporations and their billion-dollar server farms. It's a real game changer for democratizing AI development.
Section 4. Small models. Big impact. But hey, what if we don't need to prune anything at all? Well, the magic number might just be 0.5 billion. A fascinating empirical study on small reasoning models shows that models built efficiently from the ground up with just 0.5 billion parameters are proving to be remarkably capable. Now, to put that into perspective for a second, the giant Goliaths of the AI world usually run on hundreds of billions, sometimes even trillions of parameters. So these tiny half a billion parameter models are completely flipping the industry on its head.
But here's the cool part. These small models don't even have to work alone. It's all about a symbiotic relationship. As the research into web agents shows, in step 1, a highly efficient small model handles all the fast, repetitive groundwork. Then, in step 2, a large model steps in, but only when it's really needed to tackle the truly complex reasoning. Finally, in step 3, this symbiotic cooperation achieves much faster and honestly better overall results than just throwing a massive model at every single problem. They're just successfully teaming up.
Section 5. Real-world parsimonious AI.
Now, I know it is super easy to get lost in all these academic theories about parameters, sparsity, and quantization, but zooming out beyond the theory, this technology is actively saving lives today. By benchmarking lightweight models specifically for deployable medical seizure detection, researchers like Isaiah Essien and his colleagues are making it possible to put state-of-the-art, life-saving detection models directly onto small, wearable, low-power devices. They are literally proving that in the medical field, less can absolutely be more when it means finally getting accessible technology to a patient who needs it.
And these practical applications extend right into the creative fields as well. Take the research by Yang-Fan He and their team. By utilizing things like lightweight adapters and temporal-aware inversion, they are taking tools that used to require massive, expensive computing power and making them incredibly accessible. We're at a point where high-quality video editing AI can now be run efficiently and at a low cost, directly empowering independent creators everywhere. No giant servers required. Which brings us to the ultimate question posed by this entire parsimony movement. In the future of AI, is less actually more? The 2026 CPAL conference showed us a massive, clear paradigm shift. By embracing proning, quantization, and these small reasoning models, we aren't just saving computer memory. We are democratizing technology. We're making it faster, cheaper, and way more accessible for everything from a standard consumer laptop to a life-saving medical device. Thank you so much for joining me for this explainer, and I hope this leaves you super eager to see what David does to Goliath next.